So we're going to talk about area between two curves and the two options that you have for finding that area. So if you have what we had in our first example of the section, something like this. We ended up taking the top curve minus the bottom curve to get that middle area. And we did that because the top curve down to the x-axis is too much. The bottom curve to the x-axis will subtract out the exact amount that is too much, and you're left with the area in the middle. So one of the options for area between two curves is to take the top function minus the bottom function and do the problem in terms of x. This is going to be your left bound. This will be your right bound depending on the problem. Your second option, I don't have room here, so I'll write it down here, is if you don't have a top equation that's always the top and a different one that's always the bottom, like here, the same equation's the top and the bottom over here, and then you have a top and a bottom that's different over here. When you have a situation more like this, you could take the right minus the left. And right minus left is actually going to be, instead of top minus bottom and going along the x-axis and collecting area, you're going to do right minus left, go along the y-axis to collect your area. And it will be from A to B, but these numbers will be y numbers, where these numbers were x numbers. So these are your two options for collecting area. I'll show you how to do one that is a right to left. So here we have a area between two curves. This is our curve that's on the right. This is our curve that's on the left. And we'll take our right curve equation, which is x equals y plus 1. You only have to write the y plus 1. And then your left equation, which would be half y squared minus 3. You take your right minus your left. It's dy because we're going right minus left, and I need to use y numbers here. So when I look at where I start, I'm going to look at that y-axis number, which is -2, and this y-axis number, which is 4. If you didn't have a picture like this, that's so nice, you'd have to find the intersection points by hand. So I'm going to clean this up a little bit, distribute that minus. So I'd have y plus 1 plus 3, which is plus 4, minus half y squared. And this would be my problem now, and I'm just going to differentiate with respect to y, which means I'm working in terms of y with y, so I don't have to do anything really different. Y squared over 2 plus 4y minus half y cubed over 3. I'll plug in 4, I'll plug in -2 and subtract. Plugging in 4 gets me 16 over 2, which is 8. Plugging in 4 gets me 16. 4 cubed is 64 divided by 2 is 32. So 32 thirds. Now I'll plug in -2. -2 squared is 4 divided by 2 is 2. Minus 8. -2 cubed is -8. With that, I'll have a positive. So positive 8 over 6. 8 over 6 would be 4 thirds. I'll distribute that minus, and I end up with integers of 8 and 16, which is 24, minus 2, which is 22, plus 8, which is 30. And then these together would be -36 thirds, which is minus 12. So my final answer would be 18.